Hello everyone. I'm glad to welcome all of you on our webinars. Finally we established connection with California, and now we will have this nice webinar, and we'll have our speaker really soon, just a couple more minutes. So I see that we have also viewers. So guys, if you can hear me, please type something to chat so I will see that you are here with us and see that you're listening to us. So I really hope you're here, everyone. So type something to chat, please. Type chat on YouTube, I mean. So I would know that you're here with us. Please, something. Yeah. Here we go again, boys. Yeah. So I see you here. Okay, just to mention that we have two possibilities of chat. So we have one in YouTube, and I see another one on Community Z. So for this webinar and for communication with you guys and for you to communicate to me, let's use the one on YouTube. So I will monitor it, and I will try to get all the questions from it and try to tell all these questions to our speaker. So yeah, please use this chat, share your opinion, share your thoughts, and this will be our main communication channel. So this webinar, second try to start it. Today it will be good, and today everything will be fine. We will wait a couple more minutes to people to come. Just want to remind you that we always waiting for speakers, and if you want to be a speaker on our JaCoV webinars, there is an email in the description of this video. So please text us anything, and you may be a speaker of next webinar. We're really glad for everyone who willing to present any topic with us here. Also, please subscribe to this channel to miss more webinars, and to click the bell button so you won't miss our future webinars. Also, we have page on Community Z, so you may go there and register so you not miss any webinars. And again, as a reminder, we have a nice conference community, Java Z Day, sorry. We have Java Z Day conference, which will be in the beginning of April. So don't miss a chance, and please register, it's free. We'll have some amount of days, I'm not sure, will be one or more. And yeah, please register for Java Z Day. Link, I think I'll post a bit later to the chat. So let's not waste the time, and I'm glad to welcome our today's speaker, Orkhan Gasanov. Orkhan, hello, how are you?
Hi everyone. I hope you can hear me.
Yeah, we can hear, okay. We can see you.
All right, great. Let me share my screen.
Yeah, just a second. Before you share your screen,
sure.
Just like a small question. Can you tell us a couple words what will be your talk about?
Yeah, actually, this talk is about comparing the APIs. So basically, today, if we, let's say, want to build an API, the de facto standard for the API that we use usually is REST. But there are, I mean, over the years, especially over the last 10 years, there has been a great alternative for it, like a GraphQL, gRPC, and so on. Each of those new solutions, they solve the very specific problems, and could be, in some cases, not always, but could be the great replacement for the rest. Basically, this talk is about comparing these three APIs, see the pros and the cons each of it, and in which particular case to use that API. Basically, it's more about for people, let's say that you're just starting your project, and you're kind of, like divided between which API should I use. I mean, I know the rest, but I also heard those buzzwords, gRPC, GraphQL, and so on, that are flying around, and which one would be the best choice for my project. So basically, this talk is give you, give you some, for you to make your, for you to make a better choice in your project.
Yeah, I really hope that after your talk, our viewers and listeners could make this choice. So let's not waste the time. Guys, I encourage you to post your questions to the chat on YouTube. We'll have some time in the end to ask these questions. And now I will share your screen.
Okay.
Yeah, now we can see it, and I will remove myself. Good luck. Let's go.
Okay, thank you. All right, let's go, everyone. As I already said, today's topic is about comparing APIs, namely gRPC, REST, and the GraphQL. but mostly comparing the REST with the other two, because REST is in our industry is the de facto standard. All right, so let's couple words about myself. My name is Orkhan Gasanov. I'm lead software engineer at EPAM. First, I want to give a brief information about myself. I have been working in EPAM for almost 5 years. Main focus is distributed systems, big data solutions, and the complex integrations. Worked in different domains. First provided e-commerce solutions for large retail companies using platforms from Oracle and SAP. Then architected and developed series of applications for an oil company. Also worked in banking and currently working in the supply chain integration. Also area of interest include big data and deep learning. All right, so let's go to our today's comparison of the APIs, namely GraphQL, REST, and the gRPC. As actually, I already mentioned that, but I wanted to one more time take a one step back and see that why this topic is important and why I selected that for our today's discussion. All right. So if we will look at the modern application nowadays, we can rarely find an application that doesn't work with the data in one or the other way. So building a robust and reliable API for exchanging data is more important nowadays than that has been ever before. So choosing relevant API from the very beginning is half of the success. So by saying that, there is no one-size-fits-all strategy. There is no one perfect API, and there is no like a flawless approach. And the goal of this talk to give you enough information for you to make the make the precise choice, or at least that the more waived choice when you will choose the API for your future project. Okay, first let's talk about the structure of our today's talk. The way I structured it, we will take a look at the API's evolution history, why certain APIs were popular at the time, and what was the pros and cons, and most importantly, which pros of API kind of push the technology further, and new APIs or ways of designing API came to existence. Kind of we will look after each of these approaches. For example, in the 80s, RPC was there. So the implementation of it, CORBA, came to existence. And after that, it was replaced with the SOAP. And then the REST came to existence that we are using still a kind of a dominant way of building APIs. And then after that, other solutions, GraphQL and RPC, gRPC came into existence, and why we are, what is the pros and cons of this approach? All right. So let's go and first take a look at the earliest API that was found around, that was around since beginning of the 80s, is RPC, which stands for the remote procedure call. As the name speaks for itself, the idea was calling the procedure or method on the server side. To do that, arguments that are passed from the client side and the return the value that is passed from the server need to be translated to be understood by the client and the client and server operating systems. As it's shown in this picture, client make a call to a server. Arguments that are passed by a client are translated by client stop, which makes an RPC call to the server. From the server side, the call is received and translated by server stop to be understood by the server. When the server returns the value to the client, the same steps are followed. RPC were used with XML and the JSON. The idea is the idea of spending less resources and getting to work and getting the work done. Found several implementation. Okay, so one of the popular implementations in 90s of RPC was CORBA. CORBA was used. CORBA uses interface definition language, so-called IDL. So basically, you define IDL, which is common interface, and then you generate stubs for different languages. You can look at the implementation in Java, for example, and see that how much code you need to write and maintain in order to make the basic call in your in the server. Yeah. All right. So let's go to the next one. Around 1998, another protocol, or we should call it maybe API, gained popularity. It was SOAP. SOAP, or people usually call it the XML RPC. It was convenient and solved a lot of problems that its predecessors had, such as maintaining stubs and the server and on the client side. But it had one major drawback. It was verbose. It's still widely used because it has been around for long, and a lot of companies adopted that at the moment, and they are still using it. Besides other drawbacks of SOAP, it includes tight coupling between server and client. All right. So around 2000s, it was clear that the SOAP was too verbose and expensive to use. Another API that would be scalable and flexible was in search. So around that time, REST, which stands for Representational State Transfer, was introduced. Unlike SOAP, it was resource-based, and the combination in combination with the HTTP verbs such as get, put, post, delete, it provides flexible way of accessing and maintaining data. So by mentioning REST, we should clearly underline that REST is not just the JSON over the HTTP, as for everyone it's easy. I understand that it's easy to understand, but it's not just the JSON to over the REST. So basically, not every JSON over the HTTP is a REST. So REST is not a library. REST is not a library, or it's not, let's say, that framework. It's just the idea. It's just the architectural style, set of principles. This architectural style and set of principles. So first was defined by the Roy Fielding in his doctoral dissertation. And as the name speaks for itself, it's a representation state protocol. So basically, the idea is that you should get anytime from the server the state of your database or whatever. So that's the main idea. And the data could be another advantage of REST, that the data could be in any format. It could be in JSON, it could be in binary, or whatever. So the point is, we can get the snapshot of data at any given time. So that's I would say that this is the perfect like a definition of REST. So we need to get the snapshot of data at any given time. As I mentioned, the REST is the architectural style, and it defines 6 architectural constraints that should be followed in order to API to be considered RESTful. So these are, as I mentioned here, uniform interface, the well-known 6 principles: client-server, stateless, cacheable, and a layered system, and the code on demand. You can read about each of these in details, what each of these means. So, but pretty much you know about them, but maybe you just like they haven't read that it's called, for example, let's say that the uniform interface, but you know about this approach in general. What does that mean? So one thing is, in real world, let's say that if you are building a RESTful API, it's not always possible to let's say that have all these 6 styles, architectural styles in your API. But even if you, let's say that they have 2 or 3, your API is still considered as RESTful. Okay. All right, let's go to another slide. And so another thing is how to measure that whether your RESTful or whether your API is RESTful or not. So there are principles that are called Richardson maturity model. Basically, it has 4 layers starting from the 0. So basically, if your API is, it's a kind of metrics. If we look at any API, we can tell that, okay, is that API RESTful or not? So the first one, the first one is the single URI and the single verb. So basically, that is the 0 level. We don't consider that as a REST API. So another one is the first level is multiple URI and multiple URI and the single verb. When you have let's say that one of the HTTP verbs and the multiple URI, in that case we consider as a level 1. Multiple URI, multiple verb, we consider that as the second level, and the last one, that is, we consider the highest level, which is the H2S. About that we will talk in the next slide. So basically, H2S stands for that the definition is pretty long. Is that hypermedia as an engine of application state. Let's say that we have, just take a look at an example. What does that exactly mean? So basically, if you look at the HTTP, if you look at the REST, so let's say that you basically, the idea is we have, for example, let's say that the HTML file that we receive, right, over the HTTP protocol. So basically, what you do in the HTML, you just go from one hyperlink to another one. You just go from one page and the other one. So basically, the idea was to do the same with the REST. So if you, let's say, let's say we have 2 endpoints, authors and books. So we send the to author endpoint the request, and we receive the author details about the author. For example, we send the request and we get the author details. For example, in this case, Fyodor Dostoevsky. And then in the second should be that we need to get details about, what kind of books that belongs to that author. So basically, in that information we receive in the links as it's presented here. So basically, the idea is that we navigate through the REST API the same way as we are navigating through the HTML file. So that's the H2S. To be honest, I rarely see that any API. Actually, I don't even remember that in my previous projects we have. In some projects we try to maintain this H2S, but most of the cases it's kind of not required and not maybe that much helpful. So, but this is considered at the highest level of the for building your API according to certain standards. And yeah. All right. So let's go and let's take one example of the REST and see what problem it. So we talked about that the advantages of REST. That states the architectural constraint, and there is so you can have your own implementation. You can use let's say that besides JSON, you can use any other format. You can use XML. You can use the text or whatever you want. So basically, you can transfer anything that you want. Let's say that over the HTTP. But let's take one example and see what problems or what cons that the HTTP REST had, which kind of pushed the technology further and created the other approaches that we can use in our projects and kind of be happy that the benefits that it gives to us. So let's say that we are building a REST API for a bookstore, and we are following. We have the following resources. We have author, book, and the store. Okay. So the first example, let's say that we hit the API and fetch all prices for books. Let me underline that that we want to receive only prices. Let's say. So in the result, so let's say that as a result, we get not only prices, but we also get the name publisher and the name publisher and the language. If let's say we want to fetch 1,000 entries, imagine how much of useless data we will transfer. So this problem is commonly referred as overfetching. So another example is let's say that we want to fetch all the stores in the US, for example, where specific publishers can be found. So okay. So to do that, we need to send the request to API twice. First, we hit the book resource and get all publishers, and the next we will hit the store resource and get all the stores in the US for particular publishers. So we have to make two requests to get the result. This problem is commonly referred as underfetching. So okay, so we have these two problems, under and overfetching. So the question is how to resolve it, because basically you are transferring over the wire that the information that you don't use, or you have to send maybe your API is located, let's say, far away from you for some cases, and you have to make the two requests to get the data that you need. So, let's take a look at this problem, and let's say that what if instead of treating an API as a resource, let's take a look at the graph database, and from where we can fetch the data, construct our query, and basically get what we want. So that's exactly what GraphQL does. It was introduced around 2015 by Facebook and supported by it. So it's not a library; it's a specification, and you can find the implementation in different languages, or implement by yourself if it's required for your particular case. Let's say some customized implementation, but I don't think it's necessary. So basically, it has only one entry point, only one. Let's say that the URI GraphQL. So where you can make your queries and get the result, get the specific result. So okay, let's take a look at how GraphQL works. So first we need to define the schema using types. Probably so for some people it's an advantage. I said that okay, I define the schema, I know what I will get, and so on. For most of the people this is like a disadvantage, because you have to maintain the schema always on the client and the server side. You have to change that if something changes on the server side, etc. Okay, all right. So in this schema, for example, in the book, let's say that the bookstore that we reviewed before, we have 4 types. Let's say name, price, publisher, and the language. Okay, so we defined our schema. We defined our schema, and let's say we need to get all prices of books. In case of SQL, it will look something like this. So basically, you make a query. In your query, you just mention that only the price that you need only the field that you need for your case. For example, in this case, the price. So basically, the problem of the overfetching is gone. We get only what we want in this case. Okay. So in case of the for example, let's say that you want to change something on the let's say that on the database. So there's a mutation in GraphQL where you can kind of change your data, do the add or modify your data. So basically, so far, this we have been talking that what problems GraphQL solved, and that is very obvious that the problem of underfetching and overfetching is gone. But what problems itself GraphQL brings, and why it's not. I mean, we cannot use it. I mean, it's not the perfect replacement for the REST. And actually, I would say that there is no perfect. As I already mentioned in the beginning, there is no perfect solution. So disadvantages is that, as I already mentioned, the main one probably is that you need to define the schema and define and support the schema. If in case of the REST, it's kind of you have like let's say that defined API, and you don't care that what's the implementation of on the server side and what's the implementation on the client side and so on. But in case of the GraphQL, you need to define and support the schema. That's probably the one of the biggest disadvantages that at least I see. So another thing is, so let's say that the learning curve for the GraphQL is much more complicated than for the REST. If you have, let's say, a team of for example, if you have a big team and you are kind of want to start with the GraphQL, or you want to, for example, let's say that migrate from the REST to GraphQL, basically the learning curve and the implementation itself and the support is more complicated than in case of the RESTs. Another thing is that it's used only JSON. Also, the basically file upload and the things like that, it's a challenge in GraphQL. And another thing is the caching. For example, if in case of the REST, you would take advantage of the caching advantages that HTTP gives you, but in case of the GraphQL, that the caching is a problem because it only uses the post for sending a request. All right, so that's about GraphQL. Now let's move to another let's say hero. I mean, today is gRPC. So around starting from the 2010, microservices became popular, and for microservices to be efficient, transfer data between the microservices had to be very fast. So we already have seen that the drawbacks of previous solutions, REST and the GraphQL. So to achieve high efficiency, gRPC was introduced by Google. It's the idea of the RPC that we already reviewed. That we are basically making a call to the method or to the function in another let's say another server. So the idea is the same, but in case of the gRPC implementation, all of the disadvantages that all of the challenges that we had, for example, in previous implementation of RPC, they are kind of solved in gRPC. All right, so let's go. So to see that what is gRPC and how it works. And actually today we will have a demo. I wanted to make for the GraphQL and for gRPC, but I think that because of the time constraint, I think that we will do only demo for gRPC today. All right, so the ideal that is used in gRPC is called the protocol buffer, or shortly proto. So here we define our service function, request and the response that will be the request that we will send and the response that we will receive. So that's simple. For example, in our case, as you can see here, we define our proto, the get book, and we give a book request, which contains only book ID. And as a response, we get the title, genre, and the price. All right. So let's take a look at what is the advantage of gRPC. Under the hood, gRPC uses HTTP2, which is a binary protocol, and one of the main reasons, actually, that's one of the main reasons why gRPC is fast. It's really fast. So, but how fast it's complicated? I mean, how fast it's? Let's say that if we will take a look at compare the gRPC and for example, let's take compare the REST, which uses HTTP1. So there are a lot of benchmark that has been done for measuring different characteristics of the REST and the gRPC. But the most important for us is the throughput per second. So on average, gRPC faster than REST 4 times. So imagine that. Basically, you can transfer over the wire four times more in gRPC than in REST, and you decrease so you decrease throughput over the wire and use the less power of CPU. All right, let's go take a look at let's take a look at the example. Let's take a look how it works. Let's say that we have 3 microservices and they interact with each other. So one of them is written in Java, another one is, let's say, written in C++, and third one is written in Python, and so on. Let's say that we need to get the data from one microservice that is written in Java. So in Java microservice, we define gRPC service that will be accessed by C++ or Python microservice. So we define a gRPC stub in C++ and the Python microservices. We can make a call to a service and get the response. So basically, in the language implementation is not so. Basically, if you define the proto, and then you can generate your server and stop and run them. Run them, and at that point for you it doesn't matter. So which language to use. But in today's example, we will use Java. Okay, all right. So as I said, we defined our proto and can generate service and stop for different languages. A list of languages are Java, Python, C, C#, Objective-C, and Node.js, PHP, you name it. So basically, you can define your server or stop in any language, and that's the beauty of gRPC. All right. So as I said, I prepared a small demo today. So let's take a look at our demo. Let's say that we have 2 microservices, and we need to demo today is for only for gRPC. And so let's say that, let's take an example that we reviewed before. We have, let's say, 2 microservices, and let's say both of them client and server is written in Java, and we want to transfer the data between them. Okay, let's take a look at our first server. All right, so as I said, IDL that is used in case of the gRPC is called proto. So here we define our request and the response. So let's say that in this case, our request is contains only the book ID, and our response is genre, title, genre, and the price. Also for genre, we define this as enum, and we put the value here. So okay, and in the book service, we are defining that the method that the value that it will take and the response that it will return. All right, so to do that, as I said, that we need to first generate stop. So first we need to generate the code and from this proto. So in different languages we have different implementation, but in today's example we are using Java, and there is a Maven plugin that we will use today that will generate the all code for us. So basically, in this demo, you will see that how it's really easy to just in order to start to use the gRPC. All right, so let's first generate our code for the for our server. All right, so let's take a look at our server, and as we can see here, yeah, as we can see here, we have the these two book and the book service gRPC that is generated for us. So that is generated by plugin. So basically, you can do the same in all other languages. You just define the schema, and from the schema, you define you generate your code that later on you write your implementation, whatever implementation you have. For example, in our case, we will write the implementation for book service. Implementation. Okay. And in our case, it extends. Yes, and so here what we do, we define a get book method. So basically, we write the implementation for our get book method that gets the book ID here. So, all right, and we override that. Okay, let me see. Yes, book request. Okay, book request, yeah, and we need to write the book response. Okay, we get the get book method. Just a second. All right. Yeah, demo is always not going as you expect. That should be an override of the get book request. We get the get book response. Okay. Oh, sorry. Yeah, that should be stream observer. I will talk about the stream observer a bit later. So, yeah. Okay. Yeah. So basically, this is here in our book service implementation, we write our implementation that for our server. Basically, if we will receive the book request, what we will want to do with that, and what we want to return to the client. So okay. So in our case, so what we will return. So first of all, let's say that we have another method that will say private book response that will get the book, and that will let's say take the ID. Okay, take the ID, and it will return us the book. So basically, let's just mimic the let's say that that we are hitting the database and we are returning that. Let's say that we are returning the a particular ID. Let's say that if we receive for ID equals to 10, in that case we want to return particular response. So in this case, let's make it int. So in this case, if it's equals to 10, then in that case we will return. So we will return book response. We will return book response, which is we are building using a builder pattern. So we are set price, for example, 10. Also we set title, let's say test, and we set, let's say, genre, let's say equal to genre equals to, let's say, fantasy, and we build that server. And in case of the, we return book response default implementation, default instance. Okay. All right. So in our case here, what we do, we response on next. On next, we are getting our get book and the request that we get. So we get from there, from our get book, we get the ID from it, and that's it. That's all our implementation that we need to write here. Okay, so we have here implementation, but also we need to have. We have here implementation, but also we need to define our server. So let's define our server, and for our server, let's call it the gRPC server. Okay. So in case of the gRPC server, what we define here, first of all, we define the server. And we define the port for it. For example, in our case, let's make it 1991, and then we define and we add the service. In our case, it will be new book service implementation, and that's it. And let's import this server. Okay. Now let's start our server. Let's start our server. Yeah, just make it exceptional. Okay. So, and let's log that to console that our server started. And for it not to quit right away, we just keep it on waiting. Wait for termination. Yeah, that's it. That's it. What we need to do. Basically, this is for the basic implementation. You can write whatever custom implementation you need, but basically that's it. So you define your schema, you generate your code, write the implementation, and write your server. Of course, in case of the production and so on, the configuration would be a bit different, much more complicated. But generally, yeah, this is the idea. How you can make the server. All right, let's start our server, and let me start it here. And let's start gRPC server. What I named it differently. Server. gRPC server. Let me see. gRPC. RPC. Okay. All right, let's start our server. Yeah, let Let's see. I am in service demo. Yeah. Okay. Let me build that actually. Should build actually. Yeah, let's build it one more time. Okay. Okay, anyway. It was not built. What was the name of it? Okay, anyway, let's actually let me start from here. All right, so we started our server, and now it's running on port 1991. All right, that's all what it takes for starting a server. And now let's go to define our client. So defining our client would be even easier. So in our case, we have the same proto file. So basically in the client, and we generate the client stuff for it. So for generating the client stuff for it, let's also generate the protobuf for it. And if we can, as we can see here, in case of the client, let me actually update that. Okay, we are in the client, and okay. For some reason, I cannot generate the. Yeah, let's rebuild from here. Okay, let's actually build it from this terminal. Interesting. Yeah, build the. Anyway, yeah, seems like yeah. Demo is not always goes as you expect. Okay. Okay, let me see. Default. Okay, which was the comment? Oh, yeah, they are generated. Sorry, it's just seems something wrong with my machine. Yeah. Okay. All right. So let's go and define our gRPC client. gRPC client. Right. Define our gRPC client. So what should we do in case of the gRPC client? As I said, in case of the client, it's even simpler. So in our case, we need to just define the in our case, we need to just define the managed channel and all right. So manage channel builder, where we define the address. In our case, it will be localhost, and the port is that we defined is 1991. All right, just let's. Okay. Okay, so let's define our book response gRPC service. And let's define our stop. Okay, the stop. So there are like different. The gRPC. Another advantage of gRPC, it's non-blocking code. So, for example, here we are defining the. In case, for sake of simplicity, we are defining the blocking stop. So we will take the book gRPC and the new blocking stop, and we will put here our channel. So basically, we are defining a unique channel. All right, new blocking stop. Yeah, new blocking stop. And now we need to book request. We need to again build the request, and so basically book request. We define here and we set the book ID. We want it to be 10, and we want to build it, and that's it. So the next one is that just to call our server, which is calling from the stop and the get book, and send the request here, and that's it. So we can print that whatever we get in the response, we can print. Okay. All right. So we don't have much time actually. Let's start our client also.
Let's get fingers crossed that it will work.
Yes. I hope so. And I don't see why it shouldn't work.
I think it should for sure.
Yeah. All right. Okay, let me run the client for the one more time, and yeah, we are sending a request. Our server is running 1991. 1991 server has started. What do you want? Anyway, so we don't have much time. So yeah, actually, our server started. It's already running. So we have started our client, and it should, yeah, it should. Probably I missed something, some small detail. But anyway, the idea is that we have started server, and it's running. Let's say that this server is written in Java. So the client that we want to fetch the data from the server, we can write in any language, for example, in C++ or whatever. And from the stop, we are making the call to the client and fetch the data, whatever we want. So it both started, but for some reason, our client does not return us the value that we want. All right, just one small remark is, let's say we have let's say that, as I said, the gRPC is a non-blocking code, and you can write that, so basically, what if you want to send not just one request from the server side, but you want to send a several requests and get only one response, or send only one request and get the several responses, and that's possible in gRPC. You can look at the underlying implementation of it. Basically, whenever it has a thread pool, whenever you receive a request, it does not block that. It does not block that thread. It just gets the response, get the request from that thread, and release that thread. So that can be used for another request. And whenever your response is ready, you just send the response to the client. So what you need to do for have, let's say, the streaming that I have already explained. Basically, you need to add only the stream keyword here, and that would be it. So for the client and for the response, and the implementation would change a bit. And I have that implementation in the GitHub. You can take a look at it. But basically, that's the idea. So that is probably it for the demo part. It did not work the way that we expected, but anyway, that the main implementation we did, we just did not get the response. All right, so let's go back to our sorry. Yeah, let's go back to our demo. So, all right. So at the end, what I wanted to say about to sum up. So basically, to sum up, as I mentioned it at the beginning, so we don't have perfect choice. So say that you need a server. Let's say that you need a server-to-server communication, right? In that case, probably the best choice for you would be the RPC. Or you need, let's say that the CRUD operations. Then the rest would be best fit for your case. Or you need to build an API that will be mostly used for aggregated results. So such as, let's say, Facebook API, where with one request, you can get all the details for the user. So in that case, probably the best choice for you would be the GraphQL. But it's more than that, as I said. It also depends that on your team composition, or let's say that how much time you want to contribute to that, and how many people will be involved into the maintaining of that API, and so on. So it's always important to remember that not to over-engineer things. So meaning that even in case of the like, let's say in some cases the GraphQL may seem the better option, but it won't be used. Let's say that you won't use it for the reasons that I have mentioned before. So that's probably it for today. That's all I wanted to say. Actually, I wanted to say more than that, but unfortunately, the time limitation and since the demo didn't go as we expected, I think that that's all what I wanted to provide today. I have a time maybe for one question.
Yeah. Well, first of all, thank you very much for the presentation. I think you may show your last slide. Probably there will be some useful links there.
Yes. Yeah, actually, this is the useful links that actually, basically, this is the links for the GraphQL and for the gRPC. I put here all the official links, let's say, but I think that they are the best ones, to be honest, especially for the RESTful API. If you have been using REST with the most of the people that I have talked over the years, they have been using the REST, but if you talk about architectural styles, they know maybe some of the approaches that are used, but they know that they don't know the exact definition. That would be very useful place to go and read about the REST and the gRPC and the GraphQL.
Yeah, thank you very much. So first of all, I want to say thank you for your presentation. It was really nice, and I hope it was useful. So fun thing that I've just in the middle of your presentation, I've discovered that we have two chats. First one is in YouTube directly, and second one is in Community Z. Guys in Community Z, hi, I see you, all your messages there. So, and we have special Q&A section in this Community Z. So what I suggest to do, as we don't have a lot of time, I've passed the direct link to this Q&A section to YouTube chat. For guys in Community Z, you may see this Q&A near the chat tab where you are looking currently this video. So please post your questions there, and we will ask Orkhan to go there and answer your questions just a bit later. So you will receive your answer, because I see a lot of questions and I don't want to choose just one of them.
Yeah, to be honest, I have a hard stop at 8, so that's why probably I couldn't stay much longer. But I can respond one question, and the rest of that we can take, and I will.
Yeah, I think let's not select the favorites here. So let's move answer to all questions. So guys, please, if you have any questions, just like after this presentation, please go to this link which I posted to YouTube channel or to the Q&A section in Community Z and just type there your question, and we will ask Orkhan to answer all these questions, so it will be just easier and faster for everyone. Saying that, Orkhan, thank you very much for your presentation. It was just really nice. I really hope it was useful for everyone who listening to us. Guys, thank you very much for joining us. Hopefully we have the session from second time. That's cool. That's cool that we have it. So thank you very much for joining us. Thank you very much for being with us. Remind you that we have a link to feedback section just right in the description, so please use it. Subscribe to our channel. Use bell button to not to miss our webinars. So yeah, I think that's it. Don't forget about Java Z Day. It will be in April. So our today's speaker, Orkhan Gasanov. Orkhan, thank you very much again.
Thank you. Thank you, everyone. And also, besides that, I have my social media links. If you will have any additional question, maybe if you want to discuss or further, so you can always reach out to me using these links. Thank you so much again for everyone for joining.
Yeah, thank you very much. So yeah, you may go to your meeting. And from my side, thank you again for being with us today. Thank you for joining this webinar. I hope you love it. I hope you still love our webinars. Yeah, and I'm glad to see you all in this new year. My name is Roma. My Twitter, you may see it here on the screen. So subscribe on us, subscribe on me. Thank you guys, and see you in our future webinars. Bye-bye.